Breaking the Wall of Breast Cancer Models. Unathi Ramashala. Falling Walls Lab, Johannesburg.
Most breast cancer research today largely reflects Caucasian populations. And this is because of a long history of underrepresentation of Black participants in both research and clinical trials. This is significant because breast cancer acts differently across racial groups. For instance, Black South African women with breast cancer are usually diagnosed below the age of 55, while white women are usually over 55. The 5-year survival rate is significantly lower in Black patients than it is white patients, and Black women are more often diagnosed with aggressive types of breast cancer. And despite these disparities, Black women are still an underrepresented cohort in breast cancer research. This is a health gap. It leads to inadequate care and poor outcomes, highlighting the need to include more African participants in research. Furthermore, most breast cancer research uses two-dimensional cell culture, which is a model where cancer cells grow flat on a plastic surface. However, less than 10% of commercially available cancer cells originate from women of African ancestry. And even though this model has been a foundational tool for research and drug development for decades, they do not capture the three-dimensional structure, complexity, and genetic diversity of real tumors across patients and populations. This has therefore led to the development of a new model called breast cancer organoids, where instead of 2D flat cells, organoids grow as 3D spheres that keep the natural structure, genetics, and behavior of its original tumor. They are made directly from tumors of patients, so they more accurately replicate the patient's own genetics. And some studies show that patients respond to treatment the same way their organoids did in the lab. Because this model better mimics the disease, they can serve as representations of patients and populations in the lab. We are therefore expanding upon this model to include organoids made from Black female South African patients, with the goal of creating a biobank of African patient-derived breast cancer organoids. Because this model will better reflect the genetic diversity of Black South African women, we can finally research breast cancer in an African context. These organoids can be used for drug screening to predict the most effective treatments for patients, as well as create treatment tailored for Black South African women, laying the foundation for the establishment of organoid biobanks from other African populations. This will further advance the global effort for personalized medicines by including genetically diverse populations. By representing African patients in these organoid models, we break the wall by making research and treatment more fair, accurate, and inclusive, and above all, better at saving lives. Thank you.